Hello everybody. We are going to talk about dimensional analysis today and a few other things. Dimensional analysis is the process of converting one unit to another that measures the same thing without changing its meaning. For example, we can use this method to convert feet to meters, which are both measures of distance. So we're going to do an example of this. So how can we express 5.00 feet in meters given that 1 inch, so I'm around the side, 1 inch is equal to 2.54 centimeters. So this right here is called our conversion factor because we know for sure that 1 inch is 2.54 centimeters. That's just the definition of an inch, I guess you could say. Now, we'll look back here. Why did I say 5.00 instead of 5? Well, we're doing significant figures this time. So, after you learned significant figures from the last video, it's time for you to apply it in this example problem. So, let's start off by looking at 5 feet, and let's try to get rid of the feet measurement and replace it. But how do you do that? The conversion factor doesn't have anything that has to do with feet. Well, wait a second. Isn't 1 feet also 12 inches? So, if you didn't know this, that's fine. So, let's write that. 1 feet is also equal to 12 inches. So we are using our daily knowledge to solve this problem. So let's get off to the side a little bit. Let's talk about how dimensional analysis works. So we don't want to change the meaning of the number. So in other words, if I multiply 5.00 feet by 1, doesn't that just give me 5.00 feet? Isn't that just the same exact thing? So I just confirmed here that you are allowed to multiply by 1 since it doesn't change the meaning of anything. Now, where am I getting at? Well, what if I said that we can multiply this 5.00 feet by not 1, but what about something like 12 inches over feet? Now, you might be like, wait a second, doesn't that give us 60? That's not equal to 5, is it? Well, here's a little secret. This conversion factor, which we got over here, is actually equal to 1. Not numerically, but in the sense of its meaning, because we know that 12 inches is equal to 1 feet. So, if 12 inches is equal to 1 feet, if we're dividing these two numbers by each other and they're exactly the same, then doesn't that just, become 1? So, therefore, think about it this way. When we are converting from one unit to another without changing its meaning, we are just simply multiplying by the number 1, but, very eloquently. And in the process, we are changing the units too. So, there's this very special algebra trick. It's called canceling out from the top and bottom. So if you're multiplying two numbers and you have something on the top and the bottom that are the same thing, you can just cancel them out. And once we cancel them out, we get to solve the problem. So if we multiply 5.00 feet with 12 inches per feet, we get 60.0 inches. Now, you might be wondering, hey, why doesn't this have 2 sig figs? There are exactly 2 sig figs in 12, so why didn't we use 2 sig figs in our answer? Well, there is something else that you have to learn. We have to know that 12 inches is exactly equal to 1 feet. So, 12 inches per feet, this conversion factor is actually an exact number. Now, what do we mean by exact numbers? Well, if something is exact, it is infinitely precise. And remember, significant figures tell us how precise something is. So technically, if you have an exact number like 12 inches per feet, because 12 inches are exactly in 1 feet, then this number right over here has an infinite number of sig figs. So if you multiply a number with 3 sig figs and a number with an infinite number of sig figs, our answer will have the lesser of the two, and since 3 is obviously less than infinity, then, our answer will have 3 sig figs. So that's something cool. An exact number is infinitely precise. So now let's erase all of this because it's getting cluttered up and messy. So I'm going to erase. And now let's think about step 2. We are at inches right now, but we want meters. So how do we go from inches to meters? Well, let's find a way to go from inches to something closer to meters. So what about inches to centimeters? Because we have this nice conversion factor up here. So we can multiply 660, that's weird, 0.0 inches by, well, if we want inches to cancel out, don't we have to put inches on the bottom? So let's just go straight ahead and do that. 1 inch per 2.54 centimeters. Our inches cancel out just like that, and our resulting answer is 152 centimeters. So we have to do one more thing. We have to convert centimeters to meters, which is our original goal. So let me just erase the top because we need some space to do the work. So let's write down 152 centimeters. Now, how do we convert this into meters? Well, from the last video about SI units, well, I think it was about 2 videos ago, we learned that 1 centimeter is equal to 10 to the negative 2 meters. So this is yet again another conversion factor that we learned in 2 videos ago. So let us use that to our advantage. So we want centimeters on the bottom. So centimeter, we don't have to put the 1 here since it's kind of implied, since if you divide or multiply by 1, it's still the same thing. So on the top, we will put 10 to the negative 2 meters. So naturally, our centimeters cancel out, and we are left with 152 times 10 to the negative 2 meters, or in other words, we have 1.52 meters as our final answer. Now, this is an exact number because there are exactly 10 to the negative 2 meters per centimeter. So this has an infinite number of sig figs. And how can you tell that things are exact numbers? Well, usually conversion factors like this one over here have an infinite precision, which means that they are exact. So conversion factors are usually exact numbers, but sometimes they are not. And we'll get into ones that are not later in the future, but you don't have to worry about that right now. Now, let us integrate dimensional analysis with unit analysis to convert between different units that are nothing alike. So in our example, we will convert mass into volume. Remember, mass is not the same thing as volume, as you should know by now. So let's try to do something. So what if I said that we have a piece of gold? So I'm just going to draw this piece of gold. The density of gold is equal to 19.3 grams per centimeter cubed. So what if I said this piece of gold was 50.0 grams? Note that there are 3 significant figures there. So if I knew this, how many cubic meters of gold do I have? Now that's a weird question to ask, but I am asking it because we have to do some practicing here. So now, because everything here is in SI units, like grams, centimeters, and such, we don't need any outside information. All we need to know is our prefixes that we learned 2 videos ago. So if we want to turn grams to volume, how do we do that? Well, let's start by writing off what we know. So we know that we have 50.0 grams of gold, and we need to turn this into some sort of volume because meter cubed is a volume. So we have this nice little conversion factor right here, and even though they are different units, it is still a conversion factor because this conversion factor allows us to go from grams to cubic centimeters, or vice versa, meaning the other way around. So we could go from cubic centimeters to grams. So that's the beauty of conversion factors. So let's use this conversion factor. If we want to cancel out grams, grams should be on the bottom since this gram is on the top. So let's put grams on the bottom. 19.3 grams, and on the top, centimeter cubed, or cubic centimeters. I have a very bad habit of saying centimeter cubed instead of cubic centimeters, but it's cubic centimeters, so just keep a note on that. So if we multiply all this out, we get 2.59067357.5. Now, we can't just keep all these units. We have to apply significant figures. So, if we have 3 sig figs here and 3 sig figs here, we have to have 3 sig figs in our final answer since we are multiplying. So, let's keep 3 sig figs. So, this 0 over here obviously rounds down to 0. So, we can just keep the 9 as it is. And we can just erase all these other digits. So we are left with 2.59. But what is our unit on this? Well, since our grams canceled out, grams, we are left with cubic centimeters. Now, all we have to do now is convert cubic centimeters into cubic meters. Now, how do we do that? Well, there are some tricks that you can do. So let's erase this and write 2.59 cubic centimeters on a new line. So 2.59, that doesn't look like a 5. Let me rewrite that 5. 2.59 cubic centimeters. Now, how do we convert between cubic centimeters and cubic meters? We know how to convert between meters and centimeters, but the cubic form, I don't think we've ever learned that before. Well, that's fine. Let's try to figure this out. So, if we have 10 to the negative 2 meters per centimeter, if we just cube all this, the cube will distribute to all the units. So we will abuse this trait in order to determine our conversion factor. So if we do this, then our conversion factor will be 10 to the negative 6 cubic meters per cubic centimeter. So we got ourselves a very nice conversion factor right there. So let's now use it. So centimeter cubed, cubic centimeters on the bottom, and 10 to the negative 6 cubic meters on the top. And our cubic centimeters cancel out, and we're left with 2.59 times 10 to the negative 6 cubic meters as our final answer. And look, that's perfectly written in scientific notation, and that's great. So let's look at one more thing. What if we wanted to find the unit for a certain measurement? Now, we use unit analysis to not only convert between two unlike units like we did right here between mass and volume, we can also use it to find the units for a measurement. So let me give you an example that comes straight from physics. So the translational kinetic energy, which is the amount of energy in a moving particle or object, is exactly equal to 1/2 times mass times velocity squared. Now, let me give you the units for each of these. So, mass is in kilograms, and velocity is in meters per second. Let me put a parenthesis around that to be specific. So, what if I wanted to know the units for translational kinetic energy? So, how do we do that from the formula that is given to us? Well, there is one way to do it. This way is to generalize all your variables as units. So let's put a question mark on the unit that we don't know, which is right there, and let's start converting these variables or numbers into units. So 1/2 doesn't have a unit, so there's nothing there. Mass is in kilograms, and velocity squared is just meters per second squared. So notice how we converted all the missing variables into their respective units as shown over here. So let me just erase this line because that's kind of confusing. So this mysterious unit is equal to this: kilogram times meters per second squared. And if we want to simplify this, we can say kilogram meter squared per second squared. And let's just put that multiply sign right there to not be ambiguous. So these two mean exactly the same thing. So this unit, which is all written in the SI units, by the way, is equal to the unit for energy. And incidentally, the unit for energy is known as a joule. And apparently, the joule, which is the unit of energy, is equal to a kilogram meter squared per second squared, as shown over here. So let me just clear the page of the ink. And if I said 1 joule of energy, I just mean 1 kilogram meter squared per second squared of energy. So by using the formula for translational kinetic energy, which is kT equals 1/2 mv squared, we are able to derive the units for energy using our basic knowledge of units and multiplication. So that's something cool. And also, you should know that the unit for energy is known as a joule. So let me just spell that out: Joule. And that's all for this video. Have a nice day, and I hope you learned a lot.